Okay, so on page 11 starts the notes for negative exponents. And we only want our final answers to be written with positive exponents. So any negative exponent can be rewritten using a positive exponent using this rule, that x to the negative a power is equal to the reciprocal. In other words, 1 over x to the a. And over here in examples, I'm going to kind of show you, and for those who were with me at the beginning of the term, we talked a little about this, I think. But 2 to the first, we know is 2. Sometimes it helps to look at what happens with an actual number. 2 to the second is 4. 2 to the third is 8. If I kept going up the ladder, so to speak, I would keep multiplying by 2. So then it makes sense that if I come down the ladder, I'm dividing by 2. Like to get from 8 to 4, divide by 2. Divide by 2. So next up would be 2 to the 0. And 2 divided by 2 is 1. And that also reinforces why anything to the 0 power is 1. The next step down the ladder, negative first power. Well, if I have 1 and I divide it by 2, I now have 1/2. And if I had a half a pizza and I divide each of those, I divide that into a half, I now have a fourth. Or like half of a $50 is a quarter, a fourth, and so on. So it's not coincidence that this 1/4 is the same as 1 over 2 to the second. So when we don't know what the number is, we're just saying x. So to get rid of the negative exponent, we write the variable in the denominator, and then the exponent, we can think of it as then he's happy there. So my high school Algebra 1 teacher was also my high school U.S. history teacher. And I think that some of how I think of this is because he used some examples that kind of crossed over history and math. And so I like to think of some of these as like there's a war going on. And the top of the fraction is like the North, and this is the South, back in the Civil War days. These people were not happy in the North. But once they move to the South, now they're happy. They're positive. So once you move it, it gets rid of that negative exponent. This only has to do with the negative exponents. It does not have to do with negative numbers. Notice with number 2, it was 3m to the negative second. That negative second power is only on the m. So the 3 is going to stay up top, but the m is going to move to the bottom, and now his exponent becomes positive. Same type of thing happens in number 3. Negative 7, this is there to test you, that's a negative number. That's a coefficient. This rule is for negative exponents. The negative 7 doesn't have a negative exponent. He stays up top. The a has a negative exponent, so he gets moved to the denominator. Now his exponent is still there, but now it's positive. And the b had a positive exponent, so he stays up top with the 7. So if we have operations, like where we add for product rule, we're still going to add. So I still added 7 plus negative 9 on number 4. I got negative 2, but I can't leave that final answer with a negative exponent, so then my final answer is 1 over w squared, with the w squared in the denominator. So same thing here. Remember that when you're adding, we're following those rules for adding and subtracting positive and negatives. So 4 times 5 is still 20. I'm adding the exponents. So 8 and negative 5 make positive 3. Then on my D's, negative 3 and negative 1 make negative 4. So this was what I got when I put these two together, but then I cannot leave it with that negative exponent, so then I rewrite putting the D in the denominator, and then his exponent becomes positive. So any part of the monomial that does not have a that has a negative exponent is going to move to the other side. It could be, there can be things where there's a negative in the denominator and then it moves into the top because it's not happy there. So he's going to move to where he can be happy and have a positive outlook, a positive exponent. Right, let's look at number 6. So at first we're just going to use the rules that we already know, and then at the end we can take care of negative exponents. Now as you start doing it more, you may be able to combine some of these steps. When I went through just on my own to do it, I might have combined some steps that maybe initially I wouldn't combine when I show you. So 6 times negative 3 is negative 18. Not an exponent, so leave the 18 there. Add these exponents together, but it is a negative exponent, so the x portion needs to be written in the bottom, and then his exponent becomes positive. Remember that the exponent is not on the 3 and the 6 because there weren't parentheses there with the exponent on the outside. The exponent only belongs to the x, so only the x needed to be moved. So in 7, A, negative 5, positive 7 makes positive 2. B, 8 and negative 3 make 5. C, negative 12 and 7 make negative 5. So then I'm going to have A to the second, B to the fifth, and then C to the fifth on the bottom. Or as you get more fluent, more used to it, when you get to that C and you see it says C to the negative 5, you might just go, oh, C to the negative 5. I'm just going to go ahead and write him in the bottom because I know that's where he's going to end up. So you start to pick up on and maybe be able to combine some steps. But initially, you may just want to simply add those exponents together and then wait until you see the answer to think about, like, okay, what part needs to move. But notice they did not all go to the bottom, only the C because it had a negative exponent. Now, you do not want to use the calculator to do negative exponents because it's going to give you a decimal, and we don't want a decimal. We want to leave it in a fraction. If you don't know, then you can use the calculator to do 8 to the second, but we know that it's going to be 1 over 64 because of the negative. So I can use my calculator to do 8 to the second power, and then just know that because it's a negative exponent, it's in the bottom. And then our P, we would have negative 10. So maybe you just go ahead, you think, oh, it's negative 10. Well, that does mean he's going to end up in the bottom with the 64. So whether you do that at the beginning or along the way, but that's what our final answer should look like. Sometimes we're going to have negatives that become positives. So 3 to the negative 4th, 3 to the 4th is 81, so that's going to be 1 over 81. And then my R, this is a 1, so 1, that's negative 4. But then negative times negative means my S becomes positive. So then I need to adjust this. Those R's are going to have to jump down in the bottom with the 81. Now they have a positive exponent once they make that move, and the S is up here on top. And I can put a 1 with it, or I could leave the 1 out. In number 8, I have to keep the 1 so that there's something in the top of my fraction. In number 10, since the s is also in the top of the fraction, I would not have to write the 1. I can, but I don't have to write the 1. Let's look down at starting with 12 there. So 12, there's more than one way to do this, but I will tell you that if I see a problem like this, I never write a negative. I just look at it. This is where there's a war going on, top and bottom. Where is there the higher power of h? Well, the higher power of h is in the bottom. How many more does the bottom have than the top? So instead of subtracting top to bottom, I'm doing 5, take away the 2 to get third power. And if there's nothing left on top, I have to write a 1 up there. You could also do 2 minus 5 and get negative 3 and then go there. Both is the same. 13, we got negative, all sorts of negatives. So looking at the C's, which number is higher, 7 or negative 2? The 7, right? And it's in the bottom. So the C's are going to be in the bottom. Not only are there 7 of them down there, that negative 2 is going to jump down there with them to make 9 altogether. Or if I do 7 subtract negative 2. For the D's, which is greater, negative 1 or negative 2? Negative 1. So the D's are going to be on top. And if I do negative 1 subtract negative 2, it becomes 1, or just D. Now, sometimes that gets a little more than people want to wrap their head around. You can also think of just taking your first step and making everything that's negative positive, which would then look like this. C to the second, C to the 7th is already down here. This D is going to come up here. This D is going to go down here. Now I've written everything as a positive, and now if I subtract D to the second minus the 1 on the bottom, that's how we get D to the first on top, and those 2 C's on the bottom add together to make the 9. So if it's on the bottom with a negative, it's going to go to the top. If it's on the top, or if there's no fraction and it has a negative exponent, it's going to go to the bottom. So in 14, 14 divided by 7 is 2. And these 2 W's are going to jump up here with the other ones because they're not happy in the south. They're going to move to the north. They're going to defect to the north. And now they're going to join forces with the north. So there were 4. Now there are 6. And it's no fraction anymore because there's nothing left in the denominator, so there's no reason to write it as a fraction. For 15, negative 10 divided by 2 is negative 5. The higher power of m is in the denominator, so I'm going to write it down there. The higher of n is in the top. There's 1 n up there, positive 1, plus those 5 move up to make 6 total. The problems like you see on the next page, 17, 18, 19, are really more commonly what you're going to see as far as something I would put on a test. where there's not negatives to start with, but there are variables in both places. So for 17, 15 over 18, first we need to reduce that. What would 15 over 18 reduce to?
2 over 6.
It is not 2 over 6.
3.
It will reduce by 3, right? We can divide by 3 to make 5 over 6. Now, looking at the A's, who wins the war, the top or the bottom? Neither, right? For the A's, it's second power in both. So the A's are just gone. They have killed each other off. There are no more A's in the world. Then we go to the B's. The B's win the war on the top. 5 take away 3. They got 2 extra guys still standing. The C's, more on the bottom, by 1. And so that's my answer. So something that has the same exponent does not appear as part of our final answer. So very much like at the beginning when we did division today, except now, like if it would give you a negative if you subtract top to bottom, you have to rewrite it. So it may be helpful just to think about where is there the higher power, because that's where it's going to appear in your answer. And then not go to a negative at all. So here I have negative 1/2. The higher power for P is in the bottom by 1. Then I move on to the Q's. The higher power of Q is in the numerator in the top by 3, because 5 minus 2. The higher power of R is in the bottom. 10 minus 3 is 7. So still reducing. And since 9 actually goes into 54, I could just put negative 6 on the bottom. That would be the same thing. Higher power of R is in the bottom. 5 take away 2 makes that now third power in the denominator. S is in the top. T is in the bottom. So if you prefer, you can rewrite it as negative 1, R negative 1/6, R negative 3, S4, T negative 4, and then move your R's and T's to the bottom. I find most of my students have pretty good luck skipping over that step and going straight to how the final answer needs to look for a problem like that one. Now, sometimes when they already have negatives in it, it gets a little more confusing. But if they don't start out with a negative, just thinking about where they're the higher power for each variable. 20 is, we're back to mixed practice, so we'll have to use more than one rule. I see a plus sign, so I should be hoping I see something with some like terms. So 4 to the negative second is 1/16. And then my x would be negative 6. So I'm just going to go ahead and put it in the bottom and make it positive 6. And y, that would be negative 12. So it's just, I'm just writing it in the bottom instead of writing it as a negative, because my final answer I have to do that with. And then the other part, 2 to the negative third, 1/8. 2 times negative 3 is negative 6. So again, I put it in the bottom. 4 times negative 3, negative 12. So I'll put it in the bottom. On that step, I could have simply written them with negative exponents, but my final answer, they're going to have to be written in the bottom. Now, I need a common denominator. We'll have to go bigger. So if one number goes into the other, we have to go bigger. So we'll have to go to the 16. So then 8 over 16, or 1/8 is the same as 2 out of 16. So the 1/8 is the same as 2 over 16. Then we can add those together to get 3 over 16. And then remember on an addition step that your exponents don't change. All right, on page 13, even problems again. Even problems on page 13, which is homework 4. Unit 4, homework 4, I guess.